Good morning, everyone. We got a question coming in today about set theory, specifically what makes two sets equal. So let's see if we can get into this here. If we are talking about two different sets, A and B, we'll say, just label these arbitrary, we can say that A is equal to B under two conditions. If A is a subset of B, then, and I should say, B is a subset of A. If these two conditions are met, then A is equal to B, right? So if both A is a subset of B and B is a subset of A, then we can say A is equal to B. Now, if you're not super familiar with subsets, this might not be terribly helpful to you. An alternative way to think about this is if these two conditions are met. If every element in set A belongs to set B, and every element in set B belongs to set A. And if both of these things are met, then we can say similarly that A is equal to B. Now, all of this is really abstract. Let's see if we can take a look at some specifics to see how this actually works. For example, let's consider the set 1, 2, 3, 4, and we'll say this is A, and the set B equal to 1, 2, 3, 4. Right, and this might be an easy one to tell, right? Because A and B in this case look exactly the same, but the principle here is what's important, right? We can say that these two are the same because, well, in fact, 1 belongs to A, 1 belongs to B, 2 belongs to A, 2 belongs to B, 3 and 3, and 4 and 4, right? And so every element of A, 1, 2, 3, and 4, also belong to B, 1, 2, 3, and 4. And every element of B, 1, 2, 3, and 4, also belong to A, 1, 2, 3, and 4. And so because every element of A belongs to B and every element of B belongs to A, they're the same. Or equivalently, we can say, since A is a subset of B and B is a subset of A is equal to B. And so these would be two examples of equal sets. I could also say, for instance, what if A was equal to 1, 2, 3, and 4, and B was equal to maybe 3, 4, 2, and 1. Now, this one might not be as immediately obvious, right? Because they don't look identical, right? 1, 2, 3, 4, 1, 2, 3, 4. In the previous example, those looked exactly the same, right? These two look a little bit different, 1, 2, 3, 4 versus 3, 4, 2, 1, right? However, when it comes to sets, we're not concerned so much with the order as much as we're concerned with just determining what elements belong to that collection versus what elements don't belong to that collection. And so in something like this, we want to note that the order doesn't matter. It's just the actual content of each set, the actual items that are listed. So the order doesn't matter, just the specific items. And so even though 1, 2, 3, 4, and 3, 4, 2, 1 look a little bit different, these are still in fact the same because we still have every element of A belongs to B, right? So A is a subset of B, and every element of B belongs to A. B is a subset of A, and so we would still say in this case that A is equal to B. So the order of the elements doesn't matter when we're talking about a set, it's just the actual contents, which ones actually belong versus don't. Now, these are two examples of sets that would be equivalent, or sorry, excuse me, that would be equal. But let me give you an example of some that are not, right? So for instance, all it takes is one element to not be in both. So if A was the set 1, 2, 3, and B was the set 1, 2, 3, 4, well, in this case, since 4 does not belong to A, B is not a subset of A, right? Because this guy here, B is not a subset of A, so A cannot equal B. So really when it comes to equal sets, all we're really worried about is whether or not they have exactly the same elements. So you can say that by either both being subsets of each other or both sharing exactly the same elements. All right, excellent question. Thank you for submitting your question. If you or anyone else watching has any other questions, feel free to post those as a comment below. I hope you found this helpful, and I hope you have a great rest of your day.